This next example looks like an exponential function. So our usual goal for exponential functions is to match the bases and then equate the powers. Since this is not going to work on this problem, 5 can't conveniently be written as 3 to a power, we can instead use the log rule where we can use log of m is equal to log of n. And the reason this is helpful is it allows us to get at the powers and bring the powers out front as coefficients. So we have x minus 2 times the ln of 5. Now here I used the natural log. You could have used the common log or log base 3 or log base 5. Really, whatever log base you would like. I'm going to use the natural log since it's less writing. Only 2 letters instead of 3. And my calculator knows how to evaluate the ln of 5 and the ln of 3, and I don't have to worry about changing the base to something the calculator can work with. So now I've got an equation like this. It looks like a linear equation because I have x to the first powers. What I want to point out is ln of 5 is a number. ln of 3 is another number. And to make this easier to work with and to keep an exact answer, I'm just going to call the ln of 5 equal to a, and I'm going to call the ln of 3 equal to b. You can type those in your calculator, but we want all the decimal places, and we don't want to have to write all of the decimal places every time. So I've got to solve x minus 2 times a is equal to 3x plus 2 times b. We're realizing that a and b are just numbers. So we'll distribute a times x. 2 times a is equal to 3 times b times x plus 2b. Now we want all the x's on one side and all the numbers on the other side, so I'm going to add 2a to both sides, and I'll subtract 3bx from both sides. So I have a minus 3b, ax minus 3bx is equal to 2a plus 2b. Since everything on the left-hand side has a factor of x, we can factor it out, and we're left with a minus 3b times x is equal to 2a plus 2b. Dividing both sides by a minus 3b gives us 2a plus 2b over a minus 3b. And now let's put the ln of 5 and the ln of 3 back in to our equation. 2 times the ln of 5 plus 2 times the ln of 3 over the ln of 5 minus 3 times the ln of 3. And that is the exact solution to this problem. If we wanted, we could combine the lns on the top and the lns on the bottom. Just for fun, let's combine those. And in order to do that, we would first write 5 squared plus the ln of 3 squared, and on the bottom, the ln of 5 minus the ln of 3 cubed. So this is the ln of 25 over 9 divided by the ln of 5 over 27. Now there's nothing else that we can simplify here because we cannot do anything with what's inside of the logarithms now that they're inside. We've just got to keep it in this way. The 5s and the 5s, we can't factor those out or cancel those out because they're inside of a function like f of x's. So remember, the natural log, the ln, is a function. If you had seen f of 25 over 9 divided by f of 5 over 27, we need to find what these numbers, what these values are before we divide them. Same thing with logarithms.